In this video, we'll talk about applications of linear equations. So let's talk about equation of a line in point slope form. So if x sub 1, y sub 1 is a point of the line and m is the slope of the line, then the equation of the line passing through x sub 1, y sub 1 with slope m is given by the formula y minus y1 equals m times x minus x1. So let's do an example. It says, find the equation of a line passing through negative 3, 8, so that means this is x sub 1 and this is y sub 1, with slope m equals negative 1/3. Write the final answer in slope-intercept form, then in standard form. So this slope-intercept form and standard form are the two forms that we discussed in a previous lecture. So y minus y1, 8, equals m, negative 1/3, times x minus x1, which is negative 3. So if we do a little bit of algebra, we get y minus 8 equals negative 1/3 times x plus 3, right? Negative 3. And so y minus 8 equals negative 1 over 3x, and negative 1 over 3 times 3 is minus 1. So in this case, if we add 8 to both sides, we get y equals negative 1 over 3x plus 7. So this format here is in slope-intercept form, y equals mx plus b. They also want us to write it in standard form. So to do that, so let me write this slope-intercept form. And so let's talk about the same equation in standard form. So we got y equals negative 1 over 3x plus 7, and we want it from slope-intercept form into standard form. So I'm going to multiply by 3 every single term, because the LCD, if you take a look at it, it's 3. So we get 3y equals negative 1x plus 21. If I add 1x to both sides, we get x plus 3y, because 1x or x is the same thing, equals 21. And this is the standard form for the equation of a line. Now let's take a look at another equation of a line passing through 2 points. So it says, find the equation of a line passing through the points 9, 3 and 8, negative 4. Write the equation in slope-intercept form. So let's call this 9, 3 x sub 1, y sub 1, x sub 2, y sub 2. And we know from the previous lectures that if I have these 2 points, I can immediately find the slope, right? M equals y2 minus y1 over x2 minus x1. So we get negative 4 minus 3 over 8 minus 9. So we get negative 7 over negative 1, which is 7. So that's the slope. Now, if we have 1 point, and I'm going to pick this point, and the slope, we just learned in the previous example, or in the lesson here, that if I have a point, I'm going to consider this point, and the slope, I can just use y minus y1, which is 3 in our case, equals 7 times x minus 9. So out of these 2 points, we can pick one. We just pick this one. But we could have picked the second one as well. We would get exactly the same answer. So if we do the math, y minus 3 equals 7x minus 63. Add 3 to both sides, and we get y equals 7x minus 60, and this is in slope-intercept form. This would be the slope, and this would be the y-intercept. Let me show you for this problem what would have happened if instead of picking this, we picked this one. Well, if we did that, let's see, we would have said y minus y1, well, now because we picked this one, our y is negative 4, equals m, we found m was 7, times x minus 8. So y plus 4 equals 7x minus 56. Subtract 4 from both sides, and we get y equals 7x minus 60. So again, we got exactly the same equation. Now let's talk about parallel lines. Line 1 parallel to line 2. It says graph the following lines, y equals 2x plus 4, and this one. So let's do the yellow one and then the blue one. So the yellow one, if we notice, it's already in slope-intercept form. So I can immediately say, let me start by here, y equals 2x plus 4. I can immediately say that the slope is 2 over 1 and the y-intercept is 4. So if we go to graph the line, x, O, y, we go to 4, 1, 2, 3, 4. We bubble that, right? We start with the y-intercept. And then because the slope, it's 2 over 1, and it's positive on both of them, that means we go up from this for 2 units. So this is up and this is right. So from 4 we go up 2 units, that would be 6. And then we go 1 unit to the right. And we find this point and we connect them. So this would be our yellow line. It would be the graph of y equals 2x plus 4. Now let's do the second one, the blue one. I'm going to write it here. Y equals, actually in this one, it's 2x minus y equals 6. So it's not in slope-intercept form. So what I'm going to do, I'm going to write it in slope-intercept form. This is the standard form. So if we subtract 2x from both sides, we get negative y equals negative 2x plus 6. If we divide by negative 1 every single term, we get 2x minus 6. And now again, we can see that the slope is 2 over 1, but the y-intercept is negative 6. So what does that mean? I'm going to start at negative 6. 1, 2, 3, 4, 5, 6. So negative 6, right? That's the y-intercept. We bubble that. And then 2 means go up 2 units, 1, 2. And then 1 means go to the right 1 unit. So this would be the next point. And now I'm going to connect them. What do we notice from the graphs of the yellow line and this one? Well, it's green now. I wanted to make it blue. But what do we notice between the yellow line and the green line? They are parallel, right? So line 1, it's parallel to line 2. Line 1 parallel to line 2. They do not intersect. What is, if we compare this y equals 2x plus 4, and if we compare this y equals 2x minus 6, what do we notice? Well, we should notice that the slope of line 1, which is 2, is the same with the slope of line 2, equals m2. What does that mean? So we can say that if line 1 is parallel to line 2, then the slopes are equal. If the slopes are equal, then the lines are parallel. So I can just write it like this in only one line. So line 1 is parallel to line 2 if and only if slope of line 1 equals slope of line 2. So in other words, if I know the slope of one line and I know that it's parallel to another line, I know the slope of the second line. And let's take a look at perpendicular lines, which means like the x-axis are perpendicular, they make a 90-degree angle. So here, this one, it's y equals 3x minus 7. So I can say slope of this line is 3. But let's do the second line. So here, I'm going to say 3y equals negative x plus 12. I'm trying to write it in slope-intercept form. I divide every single term by 3, so I get y equals negative 1 over 3x plus 4. So the second slope is negative 1/3. Well, these slopes, if I multiply them together, I get 3 times negative 1 over 3, I get negative 1. When that happens, when we multiply the slopes together and get negative 1, the lines are perpendicular. So that's a rule. If line 1 is perpendicular to line 2, the product of two slopes, of the slopes of the two lines, is negative 1. Or what this means is also one slope is opposite and reciprocal of the other. If that happens, the lines are perpendicular, and you can notice that this slope is positive, this one is negative, it's opposite. This slope is 3/1, and this slope is reciprocal, 1/3. So in other words, if one slope, for example, is 4/5 and the lines are perpendicular, the other one would be negative 5/4, right? Opposite, positive, negative, and reciprocal. And let's do these two examples. Let's do 38 first. So it says, basically it says find a line that passes through, so find the line or the equation of the line that passes through 3, -1, and it's parallel to the line defined by -3x plus y equals 4. So what I'm going to do first is I'm going to write y equals 3x plus 4. So I want it in slope-intercept form because that immediately tells me the slope is 3. So in other words, the equation of the line that I'm trying to find, it's passing through 3, -1, and it has the slope 3. It has the same slope as this equation because they use the word parallel. So we know now the equation of a line that passes through a point with a given slope, it's y minus y1 equals m times x minus x1. This point is x sub 1 and this is y1. So we have y minus -1 equals 3 times x minus 3. So y plus 1 equals 3x minus 9. Subtract 1 from both sides and we get y equals 3x minus 10. And we found the equation of the line that is passing through 3, -1, and it's parallel to this one. And let's take a look at 39. We want to find the equation of the line that it's passing through 6, -4, and it's perpendicular to the line defined by x minus 5y equals 1. So I'm going to start with x minus 5y equals 1. I'm going to subtract x from both sides and I get -5y equals -x plus 1. Divide by -5 each term and I get y equals 1/5x minus 1/5. So in other words, this equation has the slope 1/5. Now I'm looking for another equation that is perpendicular to this one. So the fact that this equation has the slope 1/5 gives me that the slope of the line that I want to find is actually, let me call it m sub 1, is actually -5/1 or just -5. Opposite and reciprocal because they use the word perpendicular. So now, knowing that the slope of the new line is -5 and knowing that it's passing through the point 6, -4, I'm going to use the equation of a line passing through a point with a given slope y minus y1 equals m times x minus x1. So we get y minus -4 equals -5 times x minus 6. So y plus 4 equals -5x plus 30. We subtract 4 from both sides and we get y equals -5x plus 26. This is the equation of the line that is passing through 6, -4, and it's perpendicular to this line. I hope this helps.